For the last section of Chapter 2, we are going to learn about flowcharts and paragraph proofs. So a flowchart proof is a proof that uses boxes and arrows to show the structure of the proof. And before we look at one of those, we have a new theorem here. It's called the common segments theorem. So given collinear points A, B, C, and D, so they're on the same line, are arranged as shown. If segment AB is congruent to segment CD, then segment AC is congruent to segment BD. So our hypothesis is that segment AB is congruent to CD, and our conclusion is that AC is congruent to BD. So if we know certain pieces are congruent, then we can conclude that other pieces on that line are congruent as well. So for example 1, we're going to be given this flowchart here, and we have to take that flowchart and write a 2-column proof based on what's in this flowchart. So always have to look at what is given, and they are, so that's where we start with. So it says RS equals UV and ST equals UV. And that is given. And then in the flowchart, from that we go down. So we have RS plus ST equals TU plus UV. And it says right underneath of that that that's the addition property of equality. And then our flowchart moves here to that RT equals TV. But if you notice, we can't go from that up to the one above it. So we actually have to go here. We have to go over to here for our next proof and our 2-column proof. So we can break that up and say RS plus ST equals RT. And TU plus UV equals TV. I'm going to break these up here. And that is, they tell us right underneath of it, is the segment addition postulate. And then from there, we move down. So we have RT equals TV, and that is just using substitution. And from there, we can move up over here to segment RT being congruent to segment TV. And that is because of the definition of congruent segments. So reading the flowchart is pretty simple. You just have to remember, like right here, we can't just go across, because if we go across, we'll never get up to this top one here. So we have to go from that second one up and then back down to make sure that we hit all of our bubbles there in our flowchart. All right, example 2 is use the given 2-column proof to write a flowchart proof of the converse of the common segments theorem. So they're giving us the 2-column proof, and now we have to make a flowchart out of this information. So we're going to start with number 1 there. That says AC is congruent to BD, and we have to say that's given right underneath of it. And then that's going to move into, AC being equal to BD. And that's because of the definition of congruent segments. Then we're going to come back up here, and I'm going to just start writing the numbers out of the 2-column proof because I'm going to run out of room over here to fit everything. And that is because of the segment addition postulate. And then that's going to go down here to take us to number 4. And number 4 says AB plus BC equals BC plus CD, and that's because of substitution. And it says over there because of steps 2 and 3, so they're taking things from 2 and 3 and substituting them in. If AC is equal to BD, then we can replace AC with BD, or we can replace BD with AC. So these two then would be connected because AC is equal to BD. So 2 and 4 are connected, and then 3 and 4 are connected. And then we're going to have to slide over a little bit, and then we're going to have number 5 is going to go up here. So they're only going to be 2 down. So you're only going to have columns of 2 here. And then 5 is because of the reflexive property of equality. Trying to fit everything in here, and it's not working out so good. And that's going to take us to number 6. That's the subtraction property of equality. And 4 and 6 will be connected. And then that takes us into number 7. I'm going to draw it down here because I'm off the side of my paper now. And a segment AB is congruent to segment CD according to the definition of congruent segments. And then we're going to talk a little bit about a paragraph proof. And a paragraph proof is a style of proof that presents the steps of the proof and their matching reasons as sentences in a paragraph. So before we look at one of those, we have this vertical angle theorem. And we know that vertical angles are congruent. So if angle A and angle B are vertical angles, then angle A is congruent to angle B. The second part says if 2 congruent angles are supplementary. So let's think about that. There's a lot of information there. They're 2 congruent, so that means they're 2 of the same, and they're supplementary. So the only way that 2 angles that are the exact same can be supplementary is if they are both right angles, so they're both 90 degrees. So if that's the case, then angle 1 and angle 2 are congruent, and they are also supplementary. And if they are supplementary and congruent, then they are both right angles, so they're both 90 degrees. So example 3 here says, use the given paragraph proof to write a 2-column proof of the vertical angle theorem. We're given that angles 1 and 3 are vertical angles, and we have to prove that angle 1 is congruent to angle 3. So we're given this paragraph proof here, and we have to break it up into a 2-column proof so that it looks like what we're used to working with. So in the first sentence, it says angle 1 and angle 3 are vertical angles, so they are formed by intersecting lines. So the first thing is angle 1 and angle 3 are vertical. And that is given to us. That's our first statement. Then it says those are formed by intersecting lines. So we can say angles 1 and 3 are formed by intersecting lines. And that is given to us by the definition of vertical angles. Wow. Next in our paragraph, so let's cross off. We've taken care of that. We've taken care of the intersecting lines. Therefore, angles 1 and 2 are a linear pair, and 2 and 3 are a linear pair. So angle 1 and angle 2 are a linear pair, and angle 3 angle 2 and 3 are also a linear pair. And we can say that by the definition of a linear pair. So that's taken care of. And then by the linear pair theorem, angles 1 and 2 are supplementary. So we can say angles 1 and 2 are supplementary. And angles 2 and 3 are also supplementary. So angle 2 and angle 3 are supplementary as well. And it tells us right in there by the linear pair theorem. So linear pair theorem. So then this and all of that's taken care of. And then so by the congruent supplements theorem, angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. And it tells us by the congruent supplements theorem. So that is a paragraph proof. Much easier to take the paragraph proof and turn it into a 2-column proof. They kind of walk you through the steps. And if you're given the 2-column proof and they ask you to write a paragraph proof, then you just put them into sentences and make a paragraph out of it.